Hello everyone, this is Cloud Computing and Big Data Analytics, session number 31, and we are now in Unit 3. I'm going to lecture on the topic, Introduction to Big Data, Acquisition, Collection and Transmission. In today's era, numerous social apps are being developed which result in increasing data massively every day. And when we talk about social media platforms, millions of users connect on daily basis. Information is shared whenever users use a social media platform or any website. So the question arises that how this huge amount of data is handled and through what medium or tools the data is processed and stored. This is where big data comes into light. Data are everywhere. The term of big data was coined under the explosive increase of global data and was mainly used to describe enormous data sets. Big data generally includes masses of unstructured data that need more real-time analysis. In addition, big data also brings new opportunities for discovering new values, helps us to gain an in-depth understanding of the hidden values and incur new challenges. Example, on how to effectively organize and manage such data. Datasets grow rapidly to a certain extent because they are increasingly gathered by cheap and numerous information sensing Internet of Things devices such as mobile devices, aerial remote sensing, software logs, cameras, microphones, radio frequency identification, that is RFID readers, and wireless sensor networks. Let us see an example of big data. Big data is a term used to describe a collection of data that is huge in size and yet growing exponentially with time. Big data is also data but with huge size. Some examples include stock exchanges, social media sites, jet engines, etc. Then a stock exchange generates about 1 terabyte of new trade data per day. Statistics shows that 500 plus terabytes of new data get ingested into the databases of a very popular social media site every day. This data is mainly generated in terms of photo and video uploads, message exchanges, and comments, etc. A single search engine can generate 10 plus terabytes of data in 30 minutes of search time. With many thousand searches per day, generation of data reaches up to many petabytes. The volume of data that one has to deal with has exploded to unimaginable levels in the past decade. In general, big data refers to the datasets that could not be perceived, acquired, managed, and processed by traditional and software or hardware tools within a tolerable time. But it's not the amount of data that's important. It's what organizations do with the data that matters. Big data can be analyzed for insights that lead to better decisions and strategic business moves. In 2010, Apache Hadoop defined big data as datasets which could not be captured, managed, and processed by general computers within an acceptable scope. This definition tells us two more important things. First, the dataset volumes that conform to the standard of big data are changing and may grow over time or with technological advances. Second, the dataset volumes that conform to the standard of big data in different applications differ from each other. Let us see one more definition, that is from Wikipedia. Big data is a broad term for datasets so large or complex that they are difficult to process using traditional data processing applications. Challenges include analysis, capture, curation, search, sharing, storage, transfer, visualization, and information privacy. So in this session, we have seen what is big data, example of big data, and we have seen the definition of big data. The material has been taken from these two references. This is Pavitra signing off. Thank you.